Hello, how's it going, everyone? Eulier Gonzalez again, looking right now at the React Performance, which is a course taught by Steve Keeney, head front-end engineer at Temporal, this open source durable execution platform that you can think of this like Kubernetes, but to cover specific business use cases. For example, Vercel, there's now hosting solutions that allow you to deploy your code, whatever JavaScript framework you use, whether it is React or Angular, Vue, it allows you to deploy your code and they will take care of all of these intrinsic things to install all of the necessary dependency for install iOS, install an OS, install all the necessary dependency of that OS. Also, install the or clone the repo inside of this OS, guest OS. So install all the necessary dependency that your application from the repo that you clone now need to, as well as now build the application and perform some continuous integration, continuous delivery. If you have tests, perform that. And lastly, if everything went well, deploy that to production so you can see that. There is a lot of inner machinery going there. But the goal of today's video is to now take a look at the passing data deeply with context, as well as scaling up with Reducer. Why is this? Because as a way to understand now how React works, and especially if you want us to write React components in the most performant way possible, it is important to understand now how that works. And if you need to look at the docs, or any time you actually take a look at the docs to clarify something, you can do that. One, but also it's important to be able to understand is this story that here on React docs is telling us as a way to make sense of React per se. Because at the end of the day, we as human, we understand, we make sense of the world through stories. And that's the reason why I'm actually doing this. So, with that, okay, well, we're going to see is now we're going to jump straight forward to the core structure here. Quickly describe is the introduction and then jump directly to React rendering. Then on the next videos, we're going to actually look at this, all right? But for right now, briefly describe the introduction of this course, and then we jump into what we really care about, which is describing this until we get into the passing data with context, as well as scaling up with reducers and context. So this course, it aims to actually know and show us how it's important to know React behind the scenes, because especially when you have some reactive issues, React performance issues, it is important to come up with, to build a tool set that allows us to diagnose these React performance issues, and then we can now come up with some solution, best practice. So the value proposition of performance in React context is it is way faster not doing things than doing things. And there's some other corollaries to that, which is it is way much faster doing things later than right now. So because of that, I also here we also look at what are the particular tools, especially when you are developing this React application, and as a way to also is detect some React performance. So first is to identify is the production bundle. That's one. Hey, Do we have that on development or on production? Because the difference is 4 times heavier than the production bill in contrast with the development. Uh, Take a look at the component hierarchy. So now you can is take a look at what's going on as well as their state. First things first, it's important to understand that all of the things that I'm describing is relevant to performance. If you have performance issue, this is this is the tool set. All right. Take a look at the take a look at the build. Take a look at the production build. Look at the components hierarchy and state. Start from then. Look at what was the strategy used to avoid re-rendering, aka using memorizations. Uh, and look at how now we are fetching things. So, for example, how can we are loading things later on with suspense API, as well as during a pickle. Well, use the transition API for that, which is now this capability that React provides us as a way to now defer rendering or having this low priority rendering. Use the first and use transition. In any case, so it's important to describe here how now React works from their docs, okay? As a way to anytime you have some doubt, take a look at the docs, right? So, first, after all, React is a JavaScript framework that allows to describe this UI interface. We look at how can we describe the UI interface using a JavaScript function, and how can we now import components, export components, understand what JSX does for us. How can we now render components conditional, as well as render list of elements. How important is the value of key as a way to notify React, hey, I want you to now keep track of this element, okay? So if you want, for example, resetting or setting the state, something that we're going to talk about that later, you can do that. And also we look at the important when you're writing your function, your React components, after all they are JavaScript function, how you need to make them pure. Why is that? Because first, there's some benefits of that. First, it allows to run this JavaScript function in any JavaScript environment. So whether it's on the browser, the server, or workers, it also allows us to catch for this component, aka we can use using memoize, we can avoid is the React rendering this component. Again, we're going to describe what rendering means. So we can now catch that, all right? And lastly is when React is computing, is calculating that, it is safe for us by using a React or describing this React components in a pure state. It is easy for us to stop that rendering and start that again, okay? So I also look at this thing called the rendering, and this is something that when React look at your components, especially when you're starting to define all of your components, it uses a tree data structure as a way to make sense of this, as a way to see these components. So React, this render tree is helpful when you understand that, because it not only allows to detect some performance issue, but also how the data flows through that, which is something crucial we're gonna use in today's video when we look at the managing a state with context and with context and scaling up context with use reducers or with reducers. So scaling up with reducer and context. So this render tree, as well as we also have the tree dependency, which is the code that we pass to our components, these utility functions. And with that, all right, what we're going to do is now give us the ability to tell or to put some code, reusable code, utility functions in our React components. And the idea here is to make this JavaScript function, this code that we're passing, small as possible. Because when you send that to the client, you want to avoid any bloated code there, any code that is not relevant for this component. Okay. So that's why they use, for example, that code elimination in contrast of the tree shaking. So this is actually some performance technique as a way to say, hey, this component, are you using these components there? Now, let me shake the tree here for you. And once we know this, the render tree and the tree dependency, we need to look at how, and when we know how can we describe our components, how can we now add interactivity to that? And that is, look at how you can handle interactivity here with the event handlers, and by passing this function to that, also how we can create a state as these are components, this is the components memory, okay? And how can we now set that memory, that component state, okay? And what is the anatomy of the user state, and what happens anytime we set the state on that, all right? And when do we set the state, which is inside of our event handlers. Not only that, okay, but also, not only that, but also is by looking at how we set our state inside of our handlers. Here, anytime you set this memory, you update the components memory, the state. Now React do something behind the scenes. It passed through this series of steps, this mechanism, as a way to now render your components, aka apply the necessary changes to the DOM, so now you can see what's changed, so the user can see your updates. So how does it work? Well, you have now three stage, or three stage, the trigger that indicate, hey, we're actually setting the state. Okay, it can be at the initial render, like this. So, for example, if we take a look at this, like this, the trigger, right? So there are two reasons for a components to render. It is a component initial render, which means they create root, in this case like this, root render. Okay, it is a component initial render, or the component or any of its ancestor state has been updated. It triggers those states. So if any of those cases are, okay, so now React go to the rendering phase, which is just a fancy way to say React is calling all of these components. So because of that, the way now this rendering phase works is say, hey, if this trigger happens at the initial render, aka on the root.render, all right, I want now is to create those elements here. I'm going to use the create element from the DOM, okay, the document create element, and I'm going to create all of these elements here. And I'm going to call these React components. So the output of that, which is a JSX, okay, if that contains more React components, okay, I'm going to continue call them. So whoever trigger the state updates, okay, and when it comes to the rendering phase, I'm going to now evaluate as a React. I'm putting myself in the React position, okay, in the React shoes. I'm gonna render, or I'm gonna I'm gonna call these components, okay, that cause the state update, whether it is on the initial render, okay, the root.render, or React will call the component state that trigger that state updates. So you're going to evaluate all of its properties, you're going to compute that, and you're going to store that data to later on using it on the trigger phase. So during the rendering, it's now calling all of these React components that return this JSX, and if that contains more React component, it will continue to calling until there is nothing left in the tree, in the render tree. So once you do that, now it is going to the render, the commit phase, which is, okay, now that I got this previous data that I compute, that I calculate here, now let me apply, if this triggering happened on the initial rendering. So what it's going to do is to now append those elements to that using the append DOM API. So now that it creates those elements on the initial render, okay, then it's going to append that if this is on the initial render. However, if this was caused during a re-render, which means during a component that re-renders, okay, so what I'm gonna do, React say, is this data that I compute on the rendering phase, I'm gonna compare that, okay, and if there's difference, I'm going to apply the necessary DOM updates to that. So once it does, once React does, once React do that, well, it is time to make those states up, or to apply those DOM updates, as long as they are different, between renderings, between components, React components, and therefore the browser detects those changes and now renders the page. So this process is something that is very, very, very interesting, you know, and this process is done over and over and over and over and over. So being able to describe what's going on here is something that can give you now more clarity about what's going on here. And when you're writing your components, you know way much more what it's doing, what is happening down there, you know. All right, that's good. So far, so good. So far, so good. So, yeah. So, because of that, then we look at now when we set the state, what actually happened. Okay, we can think of the state as a snapshot. So, anytime you state, so the state values change is on the next render, and you can think of any time you're using a handler to set the state. React during the handler evaluation, the handler functions, is going to fix the state value for you. And also we look at how can we now queue series of states updates, which is something interesting when you are dealing with async operation instead of your handlers. Okay, that's quite interesting. And this might go. This is something that we're gonna touch down later. But once I did this, okay, yeah, totally. So once I did this, totally. So once I did this, yep, yep. So once I did this, yep. So once I did this, so when we did this, uh, exactly. So once we did this, okay, um, especially on the state snapshot, once we know and when we know how can we uh, update series of states during the handling, all right. So once we know that we can queue series of state updates uh, in the event handlers, we also look at, all right, then how can we now update object in states, arrays in states. So we can do that by returning as a new state and using immer as a way to now provide you a consistent way to state updates in a mutable sense, right? So finally, that we know how can we add interactivity to our state, then we need to know is now how can we actually scale those components. It's like how can we now how can we now is managing our state, especially as our components grows and grows and grows. Okay. Uh, so here it's important to look at how React. The thing that we're gonna look here is, all right, how to organize our state. How can we now make the state update logic maintainable, all right, as well as how can we pass data to distant components. So first thing first, we look at reacting to inputs as a way to now understand that how can we describe our components, okay? For example here, how can we now declare components uh, or exactly how now describe our components but the React way, okay, by looking is at this mental model that React provide us to, right? So this is started to make this is something that's starting to slowly make sense. Totally, especially on English. Uh, yeah, yeah. Oh my God, that's completely true. Oh Jesus, Nick. Because now here we are looking is at managing a state, and how now we're going to see how React provide us this mental model as a way to create these components the React way. Okay, so to prevent any, so to avoid any ill behavior or shooting our foot, right? Shooting our foot. So to prevent any ill behavior or shooting our foot. So that's quite interesting. that's quite interesting. So that's the reason why we're looking now at reacting to input with state. Okay, so now that you have this memory, we're gonna react it to that input with state, and that input here is, well, this model that now React say, instead of doing things in an imperative way, let's go with this declarative way. So in an imperative way, it's pretty much like, well, that you are now going to is anytime you're creating an element or pick an element and say, hey, document get element by ID, and if you want to implement is a password text followed by a button, and if you want to click or press down the button, you show the password, and if you remove that, or and if you press up, okay, or you release that, now you're gonna see the password type input. So doing that in an imperative way is something that works, but it makes harder to maintain. So the value proposition of reacting here is say, okay, I'm gonna do this but I'm gonna do that in a way that I'm gonna do that in a way that now it makes much more easy to create all of these user inputs or interactions. So the TLDR of this, okay, is that identify the different visual states, okay, reacting input with states, okay, exactly, reacting input to a state, identify the different visual states, okay. Now determine what triggered those state updates. It can be is human or computer, okay. So human interactions, clicking here or typing there. Computer inputs can be is uh, network or fetching data from the server, waiting for this image to load. Uh, so all of this, so are triggers, okay? Determine what trigger those state updates, and then, well, represent those states with in-memory use state as a way to then eliminate or remove any non-essential states. Therefore, you now connect the handlers to set the state. So now things started to make a lot of sense here because now we're looking at the reacted to input with states, and I think this is something interesting here. Reacting, reacting to input with states, and those inputs are, as I mentioned, right? Mm, 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 reacting to input with states. Hey, I'm gonna react to this input. I'm gonna react to this input. To this input. Interesting. Okay. Reacting to input. Okay. All right. Okay. Okay. So now that we look this mental model that React give us, then it make more sense of how can we need or how do we need to organize our states, okay, uh, in a way that, yeah, how can we exactly, so how can we now organize our states, okay, also following is this database engineering concept, which is normalization, normalize the database, which means that eliminate redundant or duplicate data. So in this case, the way how can we organize our state is by, well, a couple principles. Group states, group related state together, avoid any contradictory states, avoid any redundant state, which means that, hey, can I get this data from its props or from its state, okay? Also is avoid any duplicate state because keeping sync is quite hard. And lastly is avoid deeply nested objects. We also look at that, how interesting was to see that, and when you're going to create this selection, it is important to use this the key for that. Okay, that's quite interesting. That's quite interesting. That's quite interesting. Totally, totally, totally. Oh my god, yeah, it is. Oh my god, yeah, it is. Mm-hmm. Anyway, yeah. Oh my god, that totally it is. Yeah, yeah. Oh, nigga. All right, okay. So in any case, mm-hmm. Wow. So after that, I also look at how can we use map as a way to do this multiple selection. That's brilliant, bro. That's brilliant, brilliant to select, to pick, to check all multiple elements there. Okay, Holy moly. It's something I'm also gonna put this in this Trello clone. Alright? I'm gonna create all of this column, I'm gonna create all of these cards, and I also create this model per se. Mm-hmm. 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 Okay. All right. All right. Next one is that all right. Uh, how can we now is uh, rendering oh, because at the end of the day when you're rendering your elements, okay, the state is tied to the position in the render tree, which means that if you want to preserve the state or you want to reset the state, uh, it is important to know where that component is get rendered. Before that, we look at how can we now share states between different components. This is known as state lifting state up, and that is something interesting, okay? Because now when you have, for example, several components that share that you want to share that state, well, you remove those states from the child components. You hardcode it pass by you hardcode them. It is props as a way to make sense that actually all of those child components behave as it is. Uh, and then you also pass is the event handler followed by the state that you set in your parent. Why this is important? Because usually most of the time, as a way to design components and describe the capability of this component, it is important this, to mention them in uncontrolled and control components. So this sharing state between components is a way of how now can we talk about how we're going to design this component if it is if this is driven by state, so this is now uncontrolled component, and if this is driven by its props, this is controlled component. So that makes a lot of sense in terms of exactly in terms of describing those components. Oh my god, yeah, totally. In terms of uh, how to design this component and what's capability offering. Oh, nigga, yes. Oh my god. Oh yeah, it makes a lot of. Mm-hmm, 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 mm-hmm. Mm-hmm, mm-hmm, mm-hmm. Makes a lot of sense. And it all starts by asking questions and then describing this story. All of this makes huge sense, but especially once you understand all of this. Oh my god, that's fantastic. You know what I mean? And now it's time to put a practice in. It's like, okay, don't rely on theory, now put that at test. Okay? So okay, cool. So with that, okay, so now that we know anytime we're going to create a component, remember that we are reacting to input with states, and how to do that by following is this UI designer way of doing that. So describe the different Visual Studio, describe the different visual states, determine what triggered those state updates, okay, whether it is human or computer interactions. Then you, well, set those state updates, or you now represent those states in memory using the use states, avoid any non-essential states, and then, well, connect the handler that set the state, or connect the handler that set the state, and how you can organize your state here, okay, as a way to say, all right, now this is a concept that comes from the database engineers, in terms of normalization. So normalize your data, your states. Mm, mm. Which means is that, all right, now let's take a look at the uh, uh, state groups related state together. Avoid any contradictory states. Avoid any redundant state. Avoid duplicate states, and avoid any deeply nested objects. I also look at how can you do that, all right? Especially on creating these components. When you have these UI design patterns, UI selection patterns, all right? Now it makes a lot of sense to describe this, to have these uh, selections and multiple selections, well, like checkbox. So then we look at now how can we share state across multiple components, and the reason to do that is because it will make much more sense, even though that this is not a technical term, to describe our components uh, like uncontrolled and control component. Why is that? Because when you're going to design those components as well as to define its capability, it makes much more sense to use this terminology. Okay, so uncontrolled states is those if this component is uh, driven by states, okay, or uncontrolled component. This component is driven by yeah, is driven by its props. Okay, so now that gives us a much powerful approach when we're going to write this component, and also is when it comes to now uh, define the state, because after all React see they render tree. Now when you define components that are the same components that are on the same position, states are tied to the position in the render tree. So if you have now two components, uh, React now is if you have two components in the same position, React will preserve those states. If you have the different components at the same render tree position, React will reset those states. If you want, for example, reset the states in the same components at different position, okay, you can is now or render that component in a different position or use a key for that. And the key here is now actually keep track of the, so React is now keep tracking of this component uniqueness. That makes a lot of sense. Mm-hmm. Therefore, it is resetting the state anytime you call them here. Oh, okay. And by resetting the state is that, hey, this is the default state for that. Holy F. Holy F, nigga. Holy F. The holy F. So, for example, here, resetting the state here. Like this. Like this. So now it makes a lot of sense that when you do this kind of thing, it's like, hey, we are rendering this similar component, the same components, okay? And when you take a look at the contact, it's a, all right, I want now to is, in this case, show this by default, show this. This is interesting. No, 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 no. What you're doing here is this. Fix misplaced states. Determine whether the show email has been pressed for it. Press show email for Alice and tick show in the reverse order. You'll notice that Taylor's email that is expand now, but Alice, which has moved to the bottom, appears collapsed. Fixes to expand the state is associated with each contact, regardless of the choosing order. So the problem is that in this example was using a key here. Let me see if the actual state is associated with a tree position. A key lets you specify a name position instead of relying on its order. But this is interesting because now what you're doing here is to tell React, hey, I want you to keep track of this element, okay? And it is a state, okay? So if we are now rendering all of these components, okay? Uh, this is interesting because it's not resetting is the state for that. I mean, it's resetting is the state. I mean, it's resetting is the state. I mean, it's resetting the state, but by showing them in the proper order. So when you reorder that, when you trigger a rendering like this, because that's exactly what it's doing, when you trigger is a re-rendering, so now React is saying, hey, let me call this, let me evaluate this function here. In this case, hey, reverse is true, okay? Now you're going to make the display contact like so, all right? Evaluate this expression. If that is reverse, that's right, it makes a lot of sense, yes. Okay, now display contact dot reverse, okay? And then now triggering this, and then return this here. So it means that now it's going to actually display the contact in a reverse order, okay? And because now we have these elements rendering at the index position, okay? So now it's saying, hey, I'm going to reset the state here. I'm going to reset the state here. If we don't pass any element here, okay? All right. Then we show here. It actually is now render this element, okay? But it's not preserving the order here. You know, it's not preserving is the state there somehow. You know, or in fact, it's just preserving is the state is here. You know, exactly. It's preserving is the state at this position. That's what it's doing. It's say, hey, well, now show this. Now show this. It's preserving its state at that position. But when you say, hey, I don't want to preserve this state because that's what it does by default, okay? State is tied to the position in the render tree. So instead of doing that, you say, I just want to tie the state is to this ID, okay? Not to the position of the render tree, but to a index that I'm telling you. And of course, it actually just crashed. Yeah, it just crashed. So it's gonna type the state to the position of the so states are tied to the position in the state are tied the position to the tree. Okay. So states or a state is tied to the position in the render tree. Okay, like this. So I'm tied into the position, and this is a clear example of this. I'm tied to the position in the render tree. Okay. So if I do this, the state is tied to the position in the render tree. So by doing now the key, you say, hey, I want you to now associate here the state, okay? So state is associated with the tree position. A key lets you specify a name position instead of relying on the order. it lets you now rely on, instead of relying on the order, it relies on the order, specific order that you want. In this case, our key here. Mm-hmm. 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 So I want you to now is tie this state not to the position, but to some ID that you want to. Oh my God! Holy F, nigga! Holy F, nigga! Holy F, nigga! God, 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 God damn. God damn. Okay, holy F, bro. Holy F. Oh, Jesus. All right. All right. All right. Makes sense. Okay, move on. So then we look at now how can we make our state, or how can we keep our state updates logic uh, consistent and maintainable, not consistent, maintainable. Uh, so this is useful, especially if that state is reacting to multiple interactions. So, for example, if a particular state is reacting to several interactions on click, on copy, on so on click, on copy, on drag, okay, it will make much more sense to use a reducer, which is just a fancy name to say a function that actually take an state and an actions and return, and based on the type of action, it return a new state out of this. So this, oh my God, this is why now things starting to makes a lot of sense, because with these reducers, okay, uh, tremendous helpful when you want exactly to handle now several user interactions, okay, uh, to reacting to several UI inputs, okay. Okay, when you want to react to several UI inputs, totally, 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 totally. Okay. When you want to react to several inputs, interesting. When you want to react to several uh, inputs, whether it's human or computer, all right? Mm-hmm. Jesus. So, for example, okay, all right. So you must have some sort of uses patch D or some sort of uses patch D and D. Okay, this is a custom hook. All right. Um, exactly, you're not returning is any JSX. Exactly, only that. And how you can now use this on click and use callable, use callback, open job drawer, and that kind of thing. But here is looking at the context is the clear example of that you actually use this. Add company, no, this is hooks. All right, all of the hooks here. Mm-hmm. Hooks, offer notifier, drag and drop in context. Okay. As well as other hooks here. So you define is hooks for layouts? No, for map? Okay, come on. Bits, maps, notification, root detail, vendor profile, context auth, and other hooks. But this is interesting that you define a dispatch hook for that, and then hooks for this. Use bit model, and yeah, they use all of these hooks for handling its async data. For handling its async data here. Okay, makes a lot of sense. And this is now following is the next, exactly. So in your next, you define all of your hooks, and that kind of thing. It makes a lot of sense. Okay, okay. All right. And thunk. Okay. Oh my God. Yeah. All right. So now things starting to slow. Okay, makes a lot of sense, especially as we now use the context as a way to know use context for that. So here with our reducers, the more user, for example, like a to-do list, like so. All right. Hey, let me actually assign you a task here. So instead of actually defining is all of this user, I mean, you can define is all of your component here. Hey, this is a component. Okay, you can call this like list or item or task list. Okay, what they have is this, and you're going to now emit those change. Okay, so on edit, so you're now going is to accept is the what does what triggered those state updates. All right, what triggered those state updates, as well as it is data for that. Okay. um, as well as it is data for that. So because of that, so now it is useful to think that in terms of that. So this task app is the control component, which means that the capability of this component will be driven by its state. Holy F. It'll be driven by its state. Okay. All right. Okay. Cool. Cool. Well, it'll be driven by its state. Okay, makes sense. Makes sense. Makes a lot of sense. So, because it'll be driven by its state, okay, um, we look at how can we now transform from the use state to a reducer or use reducer. So after all, this use reducer is telling us if you have several interactions, you have to if you have to set the state or if you have to set the same state uh, for multiple interactions, for multiple triggers, whether it's inputs, whether it's human or computer inputs, if you have to define, if you have to set your state for different inputs, okay, if you have to react your state with different inputs, uh, or if your state has to react to different inputs, whether it is human or computer, so it makes much more sense to now use is a reducer. To now allows us is to keep the state updates logic maintainable by abstracting is this logic into a handler, okay, or by extracting this logic or by first dispatching these actions from the handlers and extracting the state update logic into a reducer function where you're going to set is a state and then actions using a switch, which is a good practice that we follow here, is that, well, now when you're going to return from this switch case, if that actually match is one of those cases, you're going to return that, okay? So you're going to return that like this. You're going to return is an object that this object, which will be used as a way to now set the state behind the scenes. So this is quite interesting, and especially if you want now is to, for example, define several or logics, for example, like this, like a selection. Hey, I want you to select this, and then this, and then that, and then that. You know, like a tab. So now you can not only react to that input, set the state to that using this patch. Passing is the proper data that you want to mutate or to generate a new state, in this case, not mutate. And then your reducer will get that, apply the necessary or return a new state out of that, and pass that to the React as a way to update that state. That is tremendous. That is tremendous, bro. That is tremendous, this flow. All right. Holy F. So when we're not talking about is passing data deeply with context, okay? Because this is now how we are describing is this problem known as the props drilling. You need to pass this data through its props over and over and over into the proper child that it needs to, child element. So instead of doing that, context is an alternative to passing props. So the way how this work, okay, is that you create a context exactly. So that will require some way for child to ask for data from somewhere above in the tree. And this is something interesting with context because context is answer the question. What happened when we want to a component knows it is closest data, it is closest relevant data. So that will require to some way for a child, that will require to some way to the child to ask the data to it is for to ask for data from somewhere above in the tree, which is pretty much what we are doing with props drilling. So props drilling is now say, hey, we are receiving we are receiving all of this data here through all of these components. Okay, it actually is not. It's not funny. It's not funny to maintain that kind of thing. Not at all. It's not at all. It's not. It's not beautiful. Maintain that because if any of those components change along the way, or if any of those props, or if any of those, if any of those components somehow remove from that, you break the change. You know, so that's actually not good. And with context, say, hey, we will provide you a way for these components to access to that data. But first, you need to do this. You need to create a context where you're going to store the data. Okay. Then in your component, use that context from the component. Okay. And then provide the context. Okay. And then provide the data. Okay. And then provide the context from the component that specify the data. So somehow now you are making, you're going to provide that data. So you're going to provide the context of that. So this is the three things that we need to do when we want to pass this data to distinct components. Because the problem is that we have is something called props drilling. Okay, so if we, for example, one of these components is removed, so the entire chain is broken. So the context say, all right, so let's go to now is define the context, the data that you need, use that in the component, and then provide that data. And then provide the context from the component that specify the data. They say provide that context from the component that specify the data. So context lets a pattern, even distant one, provide some data to the entire tree inside of this. Using context in close children, using context in distant children. But this is interesting because context lets a parent, even a distant one, provide some data to the entire tree inside of this. To the entire tree inside of this. So what you're doing when you create a context is to pass this data. So by creating the context, and then use the context from the component that needs the data, and then provide the context from the component that specify the data, and then provide the context from the component that specify the data. Okay. All right. So you can now have this data available in this component. Okay. But using is okay. Let's move it. So create a context. Create a context. Here we create a context here, okay, which is the data. Okay. Create a context. It's also come from React. Okay. The only argument that I create is a default value. Here, one refers to the biggest heading level, but you can pass any kind of value, even objects. Okay. You will see the significance of the default value in the next step. Then use a context, import the of course, it's a significant value is because you need to actually something by default to render here, to show this, or to access. Import the use context hook from React this is a hook, exactly. It's like say, hey, use context. I want you to have access to this context, to this data here that we define here. Mm-hmm. Interesting. So this is just a function. Here, look at this. We are importing this function, all right? And then we're exporting that as a const. But after all, this is just a function. This is a JavaScript function. It's executing this JavaScript function. And the output of this, which is something that I don't know what it is, okay? The create context here in React, okay, create context. Yeah, they create context. Where the F is this? Yeah, where in the F is this? This is the API, but I want this like this. Thank you. But no, I want this on English. Please be my guest. Okay. This is reference, create context default value, some context provider, some context consumer. This is usage, creating content, importing and exporting context from a file, and troubleshooting. You can find a way to change the context value. What it returns. Create context, return a context object. Is data. The context object itself don't hold any information. It represents which context other components reads or provide. Typically, you will use some context.provider. But this object that it returns, the context object itself does not hold any information. That's pretty fucked up. It represents which context other components read or provide. Okay. It represents which context each other components provide. Okay. It represents which context other components reads or provide. Typically, you will use some context of provider in components about to specify the context value. Exactly. Typically, you will use is the provider in components above the specify the context value, and call use context in components below to read it. Okay. Typically, you will use is the some context of provider in components above the specify about to specify the context value, and call use context some context in components below to read it. The context object has few properties. Okay, the context object has few properties, but it doesn't hold does not hold any information, only few property. The provider let you provide the context value to components, and the consumer. So some context will provide. Okay, but this provide. Okay. But this return is an object that contains the provider and the consumer. Write your component into a context provider to specify the value of its context for all components inside. So this is the way of how you depend when you define your provider. Okay. Depend when you provide your provider, you're going to pass this data down to all of the render tree. And the props value, the value that you want to pass to all the components reading this inside this context inside of this provider. No matter how deep, the context value can be of any type. A component calling use context inside of the provider receive the value of the innermost corresponding context provider above it. Some context of consumer. Before use context existed, there was an older way to read context. Like this. But now you do is like so. This is a legacy. Legacy way not recommended. Although this older way still works, but newly written code should read con- context with use context. This is, hey, I want you to read this content, okay? Instead, props, children. Okay, it has now, okay, the consumer. Okay, the provider as well as the consumer. Children, a function React will call the function you pass with the current context value determined by the same algorithm as use context. And this is you create a context. Theme context, auth context. Create a context, return a context object here whose values are a provider and a consumer. Okay, and this object, it doesn't hold any information. It just represents which context. Okay, it just represents which context other components read. You can think of this like some sort of map. Hey, this context belongs to all of these components, or is being used by all of these components. Okay. But the object itself return is that a provider and a consumer. Holy moly, bro. Oh my, oh my, oh my. Usage. Creating context. Context component pass information deep down without explicitly passing props. Call create context outside any component to create one or more context. Create context, return a context object. Exactly. Components can read context by passing is the use context. Exactly. Hey, I want to read this context. I want to read this data here. But after all, when you create a context, it doesn't hold any information. In fact, it's just, it represents is the reference. It represents which context other components reads or provide. Which context other components reads or provide. And then when you have this, which context reads or provide that. In this case, this component is provide that, and you're gonna now pass down data to all of the children components. In this case, only page. Exactly. Pitfall. Use context, always look for the closest provider about the component that calls it. It searches upward and does not consider providers in the component from which you call in use context. And they're giving you some example here. Extracting providers to a component. Okay, example of updating context. Okay, all right, okay. Let's get into this. So use the context. Use the context. Import the use hooks. Okay. Import the use context hook from React and your context. So first is create the context, and the context is an object whose just represent is which component, which context that represent is, wait, what? This, it represents which component What the hell? No, it's just create context. Exactly, creating context. Because it just represent which context. Okay, it just represent which context all the components can read or provide. It's like a reference here. Hey, this component can read. Hey, this component can provide, or this component provide this context. Okay, it represents that. Makes sense. Makes a lot of sense. Makes a freaking lot of sense, bitch. Jesus. Import the use context hooks from React and your context. Currently, the heading component reads level from props. Okay. But again, okay. So when you create the, okay, this is now the way of how you can create context as a way to solve a problem called props drilling. So when you want to now pass data to different components, instead of actually passing props down, instead of actually passing down through props across all of these components, you can now have this context, okay, where first you create a context, second you use the context from the component, or use the context from the component, okay. I think this is an SVE. So use the context from the component that needs the data, and then provide the context from the component that specifies the data. So these three things: create a context, which actually creates these objects that internally represent is which context these components can read or provide. Holy moly. And then expose that is the provider or the consumer. And now when it comes to provide that, you use the provide, and and when you're going to consume, you use the use context for that. So now that we look at this, okay, and how can we make sense of that? So wrap the context provider, which is the last step, and use the context here like this. Import the use context hooks. I want you to read this data, okay, and this was defined is at the heading, and on the section you say, okay, this is the component that is going to provide this data. Import the level context, and level context dot provider, because it's export this object. God damn it. Nigga. Context pass through intermediate component. Okay, context passes through intermediate components. Using and providing context from the same component. Using and providing context from the same component. Using and providing context from the same component. Currently, you still have to specify each section level manually. Since context lets you read information from components above, each section could read a level from the section above and pass level +1. Automatically, here's how you can do. So this is okay. Using and providing context from the same component. Exactly. Using and providing context from the same component. All right. So now is when you can read the data and then provide the data as a way to perform some sort of transformation. I wouldn't do that. I definitely wouldn't do that. So now both heading and sections can read that to figuring out how deep they are and the section wrapping its children into level context. This example uses headings level because they show visually how nested components can override context, like so. But context is useful for many other use cases too. You can pass down any information needed by the entire subtree, the current column theme, the current login issue, and so on. Context passes through intermediate components. You can insert as many components as you like between the component that provide context and the one that use it. This includes both built-in components like div and components you might build yourself. So we look at how can we use in provider, using and providing context from the same components. So we read that data using the use context, which is a hook from React, and then we now import the context and we provide that, because at the end of the day, that object, when you create a context output, it provides you two options: the provider and the consumer. So okay, the provider and the consumer. So here we are looking now at context path through intermediate components. You can insert as many components as you like between the component that provide context and the one that use it. This includes, exactly. You can insert as many components as you like between the component that provide the context and the one that it uses. This is the subtree. This includes both built-in components like div and components you might build yourself. In this example, the same post component with a dashed border is rendering at two different nesting levels. Notice that the heading inside it gets its level automatically from the closest section, right? So you didn't do anything special for this work. This is the section as well as this. You got now sections here. So this is all posts, and this is now a recent post. Okay. And then you got posts. Okay. So this is your profile. You didn't add anything, right? Profile. You got profile, post. What the F is this? Okay, my profile here, which is showing posts as well as all posts. Okay, and all posts have now is sections, heading, and recent posts. And then recent posts has section, heading, and post, right? And post, right? So far so good. And post now is this uncontrolled component that receives its props from that. And then it's now able to render this. So we didn't do anything special for this work. A section specifies the context for the tree inside it. You can insert a heading anywhere and it will have the correct size. Try it in the sandbox above. and all of them will have is the same exactly. Heading must be inside of a section. And then you are now providing this totally and rendering all of this a component inside of your section, followed by the heading. And the heading here is now taking the children, okay, and render that content as it is. So now level here is reading this data from the level context, which is 0 initially, and say, hey, throw an arrow, which is quite interesting. Heading must be inside of a section. So for example, if you now do something like okay. So exactly, you can also add this a heading here. You can say, hey, heading. Okay, another one. This is okay, heading. And here we're adding is all of the heading on the post here. On any post, exactly. We're adding is the heading on any post here. Exactly. On any post, we're actually adding there. Okay. So context lets you write components. So context lets you write components that adapt to their surroundings and display themselves differently depending on where, or in other words, in which context they are being rendered. So depending on the context they are being rendered, they allow you to display them differently. So they allow you to now react to this data that you're passing here. How context work might remind you of CSS property inheritance. In CSS, you can specify color blue for a div, and that kind of thing. Similarly, in React, the only way to override some context coming from above is to wrap children into a context provider with a different value. In CSS, different properties like color and background color don't override each other. You can set all div colors to red without impacting the background color. Similarly, different React contexts don't override each other. Each context that makes you with create context is completely separate from other ones, and they tie exactly. And it ties together component using and provided that particular context. One component may use and provide many different contexts without a problem. Before you use context is very tempting to use. However, this also makes it is too easy to overuse. Just because you need to pass some props several levels down doesn't mean you should put that information into a context. Here's a few alternatives you can consider before using context. Starting by passing props. Okay? Exactly. Very clear, straightforward. Hey, have you considered that pass this data instead of a context? Make it easy for that. Extract components and pass GSX as children. Passing GSX as children like this. Wait, what? Extract component and pass GSX as children to them. If you pass some data through many layers of intermediary components that don't use the data, if you pass some data through many layers of intermediate components that don't use the data and only pass it further down, this often means that you forgot to extract some components along the way. For example, no, I don't get it. Don't get it. So if you pass some data through many layers of the intermediary components, that don't use the data and only pass it further down, this often means that you forgot to extract some component along the way. For example, Maybe you pass data props like post to visual components that don't use them directly, like layout. Okay. Instead, make a layout, take children as props, and render this. This reduces the number of layers between the component and specify the data and the one that needs it. Oh, okay. As a way to prevent use, okay, as a way to prevent that, extract component and pass GSS as children. If neither of these approach works well for you, consider context. Use case for context, theming, current account. If your app lets let the user change its appearance, dark mode, you can put the context provider at top in your app, and you can use that context components that needs to adjust their visual look. Current account. Many components might need to know the current login user. Putting in a context make it convenient to read anywhere in the tree. Some apps let you operate multiple accounts at the same time. Leave a comment of a different user. In those cases, it can be convenient to wrap a part of the UI into a nested provider with a different current account value. Many components might need to know the current login user. Exactly. For current account. Routing. Most routing solutions use context internally to hold the current route, to hold this data. This is how every link knows whether it is active or not. If you build your own router, you might want to do it too. Managing states. As your app grows, you might end up with a lot of states closer to the top of your app. Many different components below may managing a state. As your app grows, you might end up with a lot of state closer to the top of your app. Many different components below may want to change it. It is common to use a reducer together with a context to manage complex state and pass it down to distinct components without too much hassle. Context is not limited to static value. If you pass a different value on the next render, React will update all the components reading it below. And this is why context is often used in combination with state. Context is, it's not limited to static values. Oh, because this is not limited to static values. It is often used that with, oh, nigga, no. It is often, oh my God, it is often used with Jesus. Damn, okay, it is often used, I'm going to stick with React, I'm sorry. It is often, because context is not limited to static values. If you pass a different value on the next render, React will update all the components reading it below. Look at this. Okay, so because context is not limited to static value, if you pass a different value on the next render, React will update all the components reading it below. And when you say React will update, it means that, are you going to call all of those components that are reading it? Which is use context. This is why context is often used in combination with state. In general, if some information is needed by distinct components in different parts of the tree, it is good indicating that context will help. So recap, god damn. So context lets a component provide some information to the entire tree below. Exactly. Hey, do you want this data? I'm gonna provide this to the entire tree below. To pass context, you must create a context and export it using the create context that it returns an object that can represent is the which context which context, which context all the components are reading or providing them, which is the provide, or the which is a property that exposes like provide or provide or consumer, the provider and the consumer. So create the context, then read the context, or use the context with the hooks use context, and pass that created context. Okay, this is interesting because this is a hooks. It means that you are triggering here a rendering. Pass it to the use context, my context, hook to read it in any child component, no matter how deep. Exactly. And wrap the children into my context.provider value to prevent it from a parent. Context pass through any component. Exactly. Context pass through any components in the middle. Context lets you write components that adapt to their surroundings. And what they mean that what you're writing components that adapt to the surroundings is that, hey, like theming, okay, or authorization. Hey, I want you to now all of these components access to this data. Routing as a way to say, hey, this is now the active link. This is the active URL that we have, that we're currently now at the app, the web app, and also the managing state. Oh, nigga, yes, managing state. Managing state. Managing state. So context lets you write components that adapt to its surroundings. It makes sense. Before you use context, try pass props or passing GSS as children. This is quite interesting because at the end of the day, when you're creating this and when you are using context here, because you're talking is about exactly creating a context. Context lets you component pass information deep down without explicitly passing props. Okay. But importing and exporting that. But when you now want is to make use of this, to consume that, okay, React will call a function you pass with the current context value determined by the same algorithm as used context. Thus, and render the result you return from this function. React will also rerun this function and update the UI whenever the context from the parent component change. So what you're triggering is a re-rendering. What you're triggering is a re-rendering. Use context is a React hook that lets you read and subscribe to context from a component. Caveats. Use context calling component is not affected by provider returned from the same component. The corresponding context of provider needs to be above the component doing the use context call. This is some part of the rules. Okay. The corresponding context provider needs to be above the components doing the use context call. React automatically re-renders. Yeah. So React automatically re-renders all the children that use particular context starting from the provider that receive a different value. Starting from the provider that receive a different value. Starting from the provider that receive a different value. So if your components are, if you define context, if you define providers way high into the tree, it's gonna re-render, it's gonna call all of these components. Jesus. You're going to call all of its components. The previous and the next values are compared with the object is comparison. Skipping re-renders with MIMO does not prevent the children receive fresh context value. Skipping re-rendering with MIMO does not prevent the children receive fresh context value. In other words, it will still be doing that. The children receive fresh context value. If you build system produce duplicate models in the output, which can happen with Symlink, this can break context. If you build system produce duplicate models in the output, okay, which can happen with Symlink, this can break context. Passing context via context. Okay, if you build system produce duplicate models in the output, which can happen with Symlink, this can break context. Passing something via context only works if some context that you use provide context and some context that you use to read are exactly the same object. That's what happened because there's some build system that produce duplicate models in the output, which can happen with Symlink. So they must need to be exactly the same object. That's determined with a triple comparison. Holy moly. That's not good. That's not good. That's not good. That's pretty bad. 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 Well, that'll be all for this video. Take care. Bye-bye.